Okay, so here's our next compressor autopsy, and I've been waiting for one of these. I should have done it last time when I took the other compressor out of the York, but I forgot about this. This is even better. This is a bigger compressor. This is a scroll out of a train. Now, for those of you in the trade, you see this big red monstrosity. You know that train likes to do their own thing with compressors. Yeah, I mean, a lot of you remember the big old regular reciprocating compressors look like a nuclear warhead. Those you had to get directly from train. There was no cross to them. The good thing is all these scrolls, except for maybe the big green ones with the little bulge on the bottom of the oil sump, all of them are Copeland compressors. And the only difference is they have this special little, if you can see on the suction line here, and on the discharge line, they have this threaded insert thing that train does. I don't know why. They've been doing that forever and a day. Stupidest thing ever, because you can never get these off. So you have to end up replacing them anyway, so what's the point of even putting the damn things on? The good thing is, this whole big tag is the train tag, but if you peel it back, underneath there is the actual Copeland numbers. So you can get the Copeland numbers off of it, just put a Copeland compressor in here, a Copeland branded one, and save yourself the hassle of having to go through train. Obviously, on the warranty, you still have to go through train, but this one's a 2002. So what we have here is a ZR61KC TF5 306. So the Z, I think, is the series. R stands for refrigeration, medium temp. So that's air conditioning, refrigeration. 61 is the capacity, and K is the multiplier. K is 1,000. I think there's another number in there that could mean 10,000. So it's a 61,000 BTU compressor, 5-ton compressor. Now, this is a scroll compressor. So unlike a reciprocating compressor, it does not have pistons and it does not have a valve plate. What it basically has is two scrolls, one stationary and one that wobbles. And it wobbles the scroll around, and as it goes through the spiral from the outside in, it compresses the gas and blows it through the top here and out the discharge line. So these are a little bit more robust, especially for AC applications. You don't particularly see a whole lot of these in refrigeration compressors. They're starting to get more and more in there. I encounter them a lot on, probably more in freezers than with refrigerators. And in that case, they have a bunch of extra stuff in there. They usually have unloaders and all kinds of other things to make them, and temperature sensors for the heads and all kinds of funky things for those applications. But this is just a straight AC compressor. And this is actually 3-phase, and this is a burnout. This is not a locked rotor or anything like that. So it's pretty nasty inside. And also, this will go to show you what gets pushed throughout the system when you do have a burnout. Now, it's a direct short burnout, so if I go between this terminal and the case, or any three of these electrical terminals in the case, I get continuity. Now, since this is a scroll, and since it has no pistons, and it has those scrolls, it's rotation sensitive, unlike the reciprocating compressors. So it does have to rotate in a specific direction. And the way to tell that is, obviously, it's a 3-phase unit, so you can reverse the direction really easy just by reversing two of the leads. And you see the newer ones here have this idiot clip on there, so that once the rotation is set and you change the compressor, you can't screw it up. But the older ones, and some of the newer ones, still have plug-in terminals. And also, you have to want to make sure on your first startup that it's running in the right direction. And the way you do that is obviously power up the unit, let it turn on. And if it's running in reverse, you'll be able to tell right away. It'll vibrate a lot. It'll sound off. These are actually pretty quiet. And if you have your gauges hooked up, your pressures will be equalized, and there'll be no temperature change in the lines. Your suction line won't get cold, discharge line won't get hot. If it's running in the right direction, your pressures will change, your suction will go down, your discharge will go up, your discharge line here will get hot, and your suction line here will get cold. Now, I've already cut through the top of this weld here. I cut through with a porta band and a reciprocating saw, and we were able to get right through this head here. So I'm going to pan you up just a hair, and we're going to get you right over this, but I should get some gloves on there when I actually take out the internals. I want to show you how nasty it is in here. Now, I emptied out the oil, and you can see what the oil looks like. Okay, so now that's all in your system, and I don't know if you can see a lot of the particles down at the bottom there. Granted, this wasn't the cleanest bucket in the world, but some of that is from the system. Now that goes throughout the system, which is why if you have a burnout, it usually requires a flush. So you can see how black and everything is now. That should be nice and shiny, and that's all from the burnout. And what you see here on the top is your discharge port that comes straight up, goes into this head, and this head is dual walled. So you might not be able to tell, but there's probably about that much of a difference between this inside and the outside, and that's where your discharge line is. It goes right through that hole. This right here, I mean, it's copper and it looks like a valve. That's more than likely is some sort of unloader. You can see that in there. I'm trying to get the light in there. That looks like some sort of unloader, so that when this unit's down, shut off, it can bleed the pressure back into the crankcase, because you see it fits on it like this. Feed that pressure back into the crankcase here and get it off the head so it's not starting under load. And you can, I don't know if you can hear that, but I can hear something flopping closed in that. Okay, so hopefully get a little bit better shot there. And again, here, right in the middle is the discharge port, straight up, and it discharges into this, which is a seal of some sort. It doesn't really feel rubbery, but it's definitely softer than this. So it's either some sort of wear plate, some sort of gasket. And you can see this is kind of like a shell in a shell. I can stick my finger down into here, probably a good 3/4 of an inch. And this looks like an unloader that goes up into the head of the discharge line here to bleed the pressure off the head and back into the crankcase. So now let me put these gloves on, just because this is pretty nasty in here. Right in here is my suction line, right there. So that just empties into the case. My motor is down at the bottom, and my scroll plates are up here. Now this plate here, I can turn that. I don't know if that's part of the scroll or not, but like I said, what happens is the motor goes, and I think it's on some sort of eccentric, and it wobbles. It doesn't rotate, it just wobbles around, and that's how it compresses the gas. So I got 4 bolts here, and to take those off and see if I can slide this whole sucker right out of there. I can see the end of the windings down there. They look pretty fried. We're going to see how much of this we can actually get apart. Okay, a big thing that I noticed here is, unlike the reciprocating compressor, this isn't on springs. This is in there pretty tight. But it runs a lot smoother because it's a rotary motion instead of an up and down motion. Picture, say, a regular car versus was it the Mazda RX-8 and Honda 2000 that have the rotary engines. They run much more smoother because all the centripetal force is out and away from there, so it's going to want to rock like this if anything, but it's bolted down and the shoes take it, whereas the other compressor is just bounding up and down. So I got those 4 bolts up. I want to see if we can remove this whole thing here. Alright, so there's your scroll, and there's the top scroll. So this is the one that's hooked to the motor. This is the one that moves. And here's your stationary scroll. Okay, so you can see that's the extent of your movement. And I'm trying to see how. Alright, so there's the eccentric right there. See, I don't know if this motor's gonna turn on me. I might not be able to. Oh, no, I can. Okay. So that goes into there. I'm just trying to figure out the movement of this right now. So if that's going to turn, see, it's hard because I can't get anything. We'll see if we can get this on the bench and make it turn and see if we can see the scrolls compress each other. But like I said, you can see here, here's your stationary scroll right there, and that mates with this internal scroll, and all they do is wobble together, and you can see the extent of the motion there. You can see the wear mark and outside this nasty stuff. So you see that right there. You see the extent of the motion that this turns, and it's not much. Now, like I said, this doesn't turn like that. All it does is wobble around just like that and engages this scroll, and as it does, it progressively squeezes the refrigerant from the outside in and around to the center and out that port on the top. As you can see, no valves. I'm not quite sure what this ring here is on the top. This may be some sort of oiling mechanism or something. If this turns at all, I don't know if that's supposed to turn, because there's a pickup tube here. Goes into something. We'll see if we can get that off too once we get this out. But you can see there's the whole stationary scroll. Here's a plate, and that right there is the motor, which I don't think I'm going to be able to get any further than this. We can try though. Yeah, no, I'm not going to be able to pull those windings out. Well, actually, hell, we might. You know what? You can see this dimple here is holding in this whole cross member. So let me get a drill and let me see if I can drill those out and pop this whole bracket out. Now, it took some finagling, but looks like we managed to get her out. Haha! I win! Whoa! That is toasty! Yeah, that's a classic burnt winding. Now, that's just a little bushing to key the shaft. No idea what that is. Some sort of bearing surface. You see how dry it is in there too. Wasn't expecting that. And that right there is your motor. Oh, she is super crusty. Yeah, let me go put my gloves on. Alrighty. Oh, come on. I bet you there's an oil slinger or something on the bottom of this. There's your oil port right in the middle. I bet you there's a plastic slinger on the bottom of this. It's fanning in the oil and pushing it right up this tube, and that's what I'm caught on. Let me grab a pair of pliers, a channel locks, and just see if I can break it. I'm assuming it's plastic. It sounds like it's plastic. Okay, let's see if the Fonzie method works here. Bastard. Oh. Oh, yep. Yeah. Yep. Plastic oil slinger right on the bottom. So there's the rotor. There's the windings. So she's definitely failed. So what happened here, and I'm looking down in, you can see all, well, some of this grit and nastiness in here, like the powdery stuff. The metal flakes are all from me. But you can see all the way down in there, there is an oil sump, and that's what this would spin and pick up the oil. And there's a little vein in there, and it would more than likely just push her right up here, and that would give my oiling for the head. So let me just clean this off real quick, and we'll see if we can put the head back together again, and maybe see how this makes the eccentric move. And what I'm seeing here is something a little bit interesting. Yeah, look at that. Well, that failed right there. That failed. That's probably what burnt out the winding. We'll get some close-up looks at this, but I see all the scoring on this here, and that tells me that this is a bearing, and this galled something fierce and pushed up all the metal on the side, and that's what jammed it. And just look at its mating pieces here. Yeah, you can see all the ridges in there. And right there, you can actually see where it welded itself from the heat. You see that? Right there. Look at that. That's our failure. That's our failure point right there. Look at, there's nothing left of this. It's brass goo. That's what that is. Oh God, yeah. There's our failure. So, more than likely happened, you can see it right there. You can see the chunk taken out of it. This is your bearing surface for right here. And you can see it wore a shaft right out of there. And you can see the other, this is actually a split bearing. You can see the split right there. And you can see all the metal that pushed up right there. So that's what actually made this compressor fail. This failure in turn made these windings overheat. When these windings overheat, the insulation between the lines themselves burn, and then it arcs out and you get this disaster. So so this baked for a while, which broke down all the oil into this sludge. So this got super hot from that bearing failing, which in turn, you know, like I said, overheated this to the point of turning the oil into nastiness, and then it finally let go on one of those copper lines there, and fried it. You can actually see all the line that they used to tie the windings together. It's all broken, all that string. Now to try to point out which wire exactly went poof. I'm leaning towards somewhere in here, just because it's way black over here. I can still see copper over here, and this doesn't look too bad, but right here it's pitch black. So somewhere in there is probably where the blowout is. So let me just clean some of the sludge off of this and see if we can get the scroll back together again and make it actuate by hand. Okay, we're going handheld just to take a peek down in here. So you see at the very bottom, that's where the other shaft is in that little bearing there. Okay, and you see how the sump was set up a little bit. It's on a little raised platform. There's a hole right there in the middle of that bearing seat, right? And there were those little fins and fans in the bottom that kick the oil up right through the middle. Now, like I said, here's the winding, and what happened was the bearing failed on the actual head, which I'll show you, and it jammed the motor. And you can actually see parts where the rotor rubbed up against the bars there. And like I said, over here doesn't look too bad, but over here you can see it's very, very black. So I'm assuming our short is somewhere in that general vicinity there. And you can see how much nasty crap is in here, and how much metal shavings. Now, a lot of this is probably from me, but some of it is also from just the compressor itself. You'll see how much metal actually shaved off the shafts. So let me set up on the bench, and we're going to stack this assembly up just like it was in here. We're going to turn it and kind of show you how this works. Okay, the trick here is just trying to get a good light source. Alright, so this is the rotor that was in the bottom there, and you can actually see where it rubbed right there. And at the bottom here you can see little fins in here. That looks like an oil pickup, and what's weird is that, I mean, that looks like an oil pickup, and that's an oil port there. Oh yeah, there's a hole all the way through. Alright, so there's a hole all the way through this shaft here right to the top, so I'm assuming that's how your oil gets up there. Now, here's the bearing that failed. You can see we got a split bearing. I'm assuming it's a split bearing. I see the line there. You can see how galled that is. And you can see actually all the raised material right here. See that? All right in there. And you see the brass wearing off from the actual bearing. So that's the one that failed. The one in the bottom, pretty good. So we had this went on next, and you can see this plate here is where the shaft kind of wobbles around. That doesn't look too bad. You can see in there. I mean, it's got some little marks in there, but nothing really big except for right here, which is probably once that bearing in there failed. That's where it kept whacking against. And you can see, I think you can see in there, the oil port. And that oil port goes, trying to see where it comes out, right here. Right there. Alright, and then here's the other half of that bearing that failed. You can see how galled it is in there. So, and you can see it actually raised the ridge. So this sat in here like this. Alright. Then we had this, which was is the actual bearing surface of the movable scroll here. And you can see this from that bearing flopping around. You can see how much play I have in that actually. From this flopping around, you can see it was hitting in a certain spot, and you can see it actually wore right through it. I'm trying to get the light in there a little bit better. You can see that right there. Wore that surface right through. So that sat in there like so. And then this sat up here somehow, like that, I think. Yeah, that's the only way it can go. So, and then this was shaft bushing, and you can even see the wear in this. This was getting the hell banged out of it. You can see wear there, and you can see it in that's supposed to be shaped like a D, and it's not anymore. You can see that there. That goes in there like so. Movable scroll goes on here. Yeah, there we go. Had that on the wrong way. Movable scroll there. And then these two little tabs lock it in. And then our valving plate, or it's not a valve plate, but our head here and our stationary scroll. That goes right on the top. Now, like I said, I'm not quite sure what's under here. I'm going to grab a screwdriver real quick, see if I can pry that off. I don't think I'm going to be able to get it off, but I'll give it a shot. Okay, I actually got it off. It looks just like a seal. There's nothing underneath it. Except for that little, there's a little tiny port there. Other than that, it's just some sort of seal. For what? Not quite sure, but... Alright, so let's link these scrolls up. Okay, through a little bit of trial and error we were able to get this on. The problem is you can see that it's kind of like an X, but these are elongated on the side, so it has to line up in a certain position. So now, if you look down the throat, you can see that's the edge of the scroll, the discharge port. And as we rotate it, you can see the movement that it makes. And you can see up here, and we'll get a better look at this, you can see the outside plate there. You can kind of see the motion that scroll is going through there. And we'll flip this around for a better view. But I just wanted to show the valve plate in there. Well, not the valve, but the end of the scroll there. Now, what you can also see here too, if I flip it over this way, is right here is the intake port of the scroll. And you can see as I turn the motor, you can see the movement of that. And it's going out, it's going down, it's coming out towards you, going up, going in, and squishing down. Now that's why it has to rotate in that direction. If it rotates in the other direction there, you can see it's not going to compress anything because it's going the opposite way. Alright, and you can see the rest of the plate here, the rest of the movement from it. So let me get you a really good top-down shot with the motor removed, and you can see how that whole plate moves and how everything in there wobbles. But like I said, that's the intake. So right there it's intaking the gas. Right there it's starting its compression and forcing it through the outside of the scroll. And right there it's completing its compression stroke and shooting it out. So intake, compression, out that way, and intake, just like that. Okay, so here's a straight down shot with the actual stationary bearing there removed, and this is where the shaft would go and turn exactly like this, so you can see the actual movement that this whole mobile scroll is going to make. So that's its motion around that plate right there, and you can see, I can turn it around this way, that it's just moving side to side and oscillating. You can see it there. So the only thing that's actually rotating would be the motor itself. The actual compression mechanism, all that's doing is wobbling against two scrolls. And again, from this side, if you look down in there, there's that other plate where it discharges up. And you can see it's just sliding on these pins is basically what's keying everything in to stop the rotation and stop the oscillation. Right here, that holds it in place, and then this, see this tab lines up into those slots, and these two tabs line up into the slots in the movable scroll, and that's what keeps everything from rotating and getting the oscillation stroke. So, you know, I've never seen the inside of one of these before, so now I have a little bit more of an understanding of exactly how it works. Like I said, I still don't know exactly what this top piece is plugging and its exact function. You can see there are still holes in the top here, so I'm assuming there's something with pressure relief. So you get the basic idea of how this works, and hopefully better understanding of how a scroll compressor works and why a scroll compressor can only run in one direction. And you know, we hope you enjoyed this video, and we'll definitely see you in the next one.